All right, so this video, we're still working within the idea of demand curves and figuring out where do demand curves come from. The purpose of this video is really, it's more algebra than anything else. We're going to start working with the idea of a budget line, and ultimately it will be connected with the indifference curve. But before we get to that very important issue, you have to understand, where does a budget line come from? So the key thing to remember with the budget line is that it's only talking about the money you have to spend over two goods. It has nothing to do with consumption. It has nothing to do with how you feel. It's strictly a dollars and cents kind of idea. So the overall idea here is we're going to start with this budget equation. So this budget equals the price of X times the amount of X plus the price of Y times the amount of Y. So all the budget is saying is we're spending it on X and we're spending it on Y, and the sum of those two expenditures has to equal our budget. So we're going to take that equation and then we're going to turn it into this equation. So it's going to be that amount of Y is equal to the negative ratio of the prices times the amount of X plus the budget divided by the price of Y. So that by itself is not very intuitive, but if you remember back to your high school algebra, this equation is in the form of line. It's our Y equals mx plus b format. So we have Y, we have the slope m, in this case it's the negative ratio of the prices, and then we have the Y-intercept, which is the budget divided by the price. And so we'll kind of explain this after we derive it. So the next thing we're going to do, we're going to go over here. We've got that budget equation that we started out with, and that makes sense. That's intuitive. If we sum our expenditures over good X and good Y, that should equal our budget. So the objective here is to turn that into the equation of a line. So that means, and we'll just say Y is going to be on our Y-axis, just for convenience. So we're going to have to do some algebra. So the first thing we're going to do is we're going to move the Y's over to the left. So we're going to subtract Py times Y from both sides. So we'll say negative Py times Y plus budget equals Px times X. We need to move the budget to the other side. Py times Y. So we're subtracting the budget from both sides. Px times X minus the budget. Again, there's nothing intuitive here yet. We're just doing basic algebra. So the next thing is we have to isolate the Y. Remember, we're going through that Y equals mx plus b form of the equation of the line. So we're going to divide through by Py, the price of Y. So this cancels out. So we get Y equals, I got to remember to put the negatives here, negative Px over Py times Y. And because we have two negatives here, that makes it a positive. We get plus the budget divided by Py. Okay? So let's look at this a little more closely. So again, the idea here is this is the slope. So our slope of this, the equation of the slope of the budget line is negative the ratio of the price of X over the price of Y. So first thing to remember, I'm not going to explain it, but I just want you to notice this, is that this is kind of in an order that's not expected. Normally we always think of rise over run, Y over X. But since we're talking about prices, which are in different units than the Y and the X, we're talking about the price of X over the price of Y, and because it's negative, it's a downward sloping line. So that's the first item. Second item is this is our Y-intercept. So what's the significance of the Y-intercept, at least based on this? Well, if we take our budget divided by the price of Y, so we're taking all the money we have to spend and we divide it by the price of Y, we get the number of units of Y that we could buy if we spent our entire budget on Y. So it's our maximum amount of Y. And that fits in with this idea of the Y-intercept. Okay? So if we were going to just quickly graph this, this budget line. So we have Y on the vertical axis, X on the horizontal axis. What we would see here is that Y-intercept, that's budget divided by PY. So that would give us those physical units of Y. We have this downward sloping line. The slope would equal negative PX over PY. And again, I just want to note again, this is in an order that seems backwards, but based on the derivation, we know it's not backwards. It's correct. Okay, this is the slope. So we have slope, we have the Y-intercept. So the only thing the equation is not directly telling us is the X-intercept. But we have this model here of, we figured out the Y-intercept, the maximum amount of Y that could be purchased. We divide the budget by the price of Y. So we know this X-intercept will be the budget divided by PX. So we've got this general, we've derived the equation. We've kind of done a simple graph here. So what does this equation represent? Well, by definition, the budget line represents all the combinations of two goods that could be purchased with a given amount of money. So as you move along from one point to the next along this budget line equation, is what's the same? Well, regardless of where we're at, we're always spending the same amount of money. Okay? So, but it's different combinations of X and Y. So if we're here, right? So this would be 0 amount of X and the maximum amount of Y. If we were down here, 0 amount of Y and the maximum amount of X that could be purchased with the budget. Okay? So again, the idea here is how we derive the equation of the budget line, what are the elements and what do they mean, how does it fit into the basic graph. So in the group work, you're going to see how all this comes together, and we'll put it together with the indifference curve to kind of find the optimal combination of goods.